Welcome back to the classroom. We are covering Module 3, Inquiry Question 1. This is the 2016 independent paper for Year 11, Question 16. We are explaining the exam. Let's go through some of the information provided. A wave has an amplitude of 20 centimeters, a wavelength of 30 meters, and a velocity of 60 meters per second. And then on the grid below, it says draw the displacement of a particle in the medium for 2 periods of the wave motion. Okay, so first what we need to know is how long does it take for one wavelength to form? How long? Let's have a look at some of the questions. We know that the wavelength is 30 meters. We know that the velocity is 60 meters per second. So using our wave equation, we can work out what frequency is. Okay, so frequency is equal to velocity divided by wavelength. Our velocity is 60, our wavelength is 30, so our frequency is 2 Hertz. In order to find the period for one wavelength, that's the inverse of frequency, so it's 1/2 seconds, which means for every 0.5 seconds, we'll have one wavelength of a wave passing through. Okay, so we can expect that it kind of goes sort of like so. Now the next question is, how tall can the wave go? The amplitude is 20 centimeters, which means we can go to a maximum height of 20 plus and 20 minus. So I'm going to draw the first wave. It's going to go up here and then it's going to come down. That's half a wavelength. I'm going to go here and then over here. And then we can draw the exact same thing again. And like so. Obviously, you probably can draw it a bit nicer than me free-handed, but this is our 2-period wavelength. Next question, it says, in the diagram, the longitudinal wave below, the particles of the medium carrying the wave is represented by the black dots. So these are all little particles that we have here. It says that the vertical lines represent, in real life, 1 times 10 to the power of negative 14 meters apart. So that's the overall length. It says, calculate the frequency of this wave if the velocity was 330 meters. So this formula will come in handy. Let's see, our velocity we already know is 330, but we don't really know what wavelength is. If we look at this graph here, a wavelength on a longitudinal wave is from one compression to another compression. So it's sort of this line across here, that is one wavelength. But I can't really tell what the wavelength is because it's not stated to a scale. But I do know each space along these gaps is this value here. So let's count how many spaces from one compression to another. We have 1, 2, 3, 4, 5, 6, 7, 8. 8, okay? So let's substitute the values in first. We have a velocity of 330. We have a frequency of so, and then we have a wavelength, which is 8 times 110 minus 14. So swap those around. And we can find the overall frequency. So that means we have a frequency of 4.125 10 to the power of 15 Hertz. You can round it off to 3 sig figs, but you know the numbers here are valid enough to leave it as it is. So that's how you can work out the period, time, wavelength, frequency of a transverse wave and also a longitudinal wave. Hopefully you found this video useful. Please give it a like to support for other videos to come out in the future, and then have a nice day.